Hello everyone, a very good morning all of you and a very warm welcome to you all to this beautiful practice session for BARC 2024. Please guys do join me fast और जो लोग already यहाँ पे मौजूद हैं respond me through the comment section if my audio and visual quality are fine. सब लोग क्या तैयार हैं BARC 2024 के थर्मल एंड फ्लूइड पोर्शन की न्यूमेरिकल प्रैक्टिस के लिए? Please make some noise through the comment section so that we can start. Am I properly audible and visible? Quickly, everybody do write in the comment section. जो लोग पहली बार मेरा सेशन अटेंड कर रहे हैं, this is my quick introduction. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi and also I have cleared engineering services examination which is conducted by UPSC. Just hold on. और मैंने सेल में भी जॉब किया है. From last 11 years I have been into teaching, guiding the students who are preparing for various competitive examination. So I hope आपकी preparation up to the mark है. Please keep your pen, notebook and calculator. और खुद से ज्यादा क्वेश्चन सॉल्व करिए एंड डू राइट योर आंसर इन द कमेंट सेक्शन. ऑलराइट, स्टार्ट करें. एवरीबडी प्लीज डू लेट मी नो इफ माय ऑडियो एंड विजुअल क्वालिटी आर फाइन. अगर आपने अभी तक मेरा टेलीग्राम चैनल नहीं ज्वाइन किया है, दिस इज माय लिंक फॉर ज्वाइनिंग द टेलीग्राम चैनल विच इज मैकेनिकल बाय चंद्रशेखर एंड ए कपल ऑफ इंफॉर्मेशन एंड देन वी विल स्टार्ट. आप लोग कुछ मेंशन नहीं कर रहे हैं कमेंट्स में. जो लोग लाइव हैं यहां पे, प्लीज डू राइट इन द कमेंट सेक्शन. Day after tomorrow on 6th of March there will be an important workshop conducted by Dheeraj sir and he will be giving you the information or the guidance how to prepare for GATE 2025 with the best possible score. So do not forget to part of this workshop and the link is already there in the description box of this session. And on 10th of March BYJU'S exam prep is going to conduct the scholarship test and based on your performance in the test you can get up to 90% scholarship in our various courses. तो एक बार जरूर डिस्क्रिप्शन बॉक्स में चले जाइए after the session to know the important links to appear for the scholarship or to register yourself for the workshop. All right, so shall we start? मेरे पास आज अराउंड 16 to 17 क्वेश्चंस हैं. देयर आर सम क्वेश्चंस फ्रॉम द थर्मल इंजीनियरिंग विच इज बेसिक थर्मोडायनेमिक्स, इट्स एप्लीकेशन अलोंग विद द हीट ट्रांसफर, और कुछ क्वेश्चंस मेरे पास फ्लूइड मैकेनिक्स के हैं. आपको पता होगा कि इन बार्क रिटन एग्जामिनेशन फ्लूइड मैकेनिक्स एंड थर्मल इंजीनियरिंग आर टू वेरी इंपॉर्टेंट सब्जेक्ट्स टू get the best possible score in your examination. चलिए स्टार्ट करते हैं with question number 1 on your screen without any further delay. Hi Kaushaki Pandey. Yes, you can download the admit card from their official website. BARC की official website से you can download the admit card. Yes, there is a question. Solve करिए. The question is from the basic thermodynamics. There are, let us read the question quickly. Question को समझिए, डायग्राम बनाइए and have a look to the options and then give the answer. Then solve. There are 3 Carnot engines. Carnot engine क्या होता है? Reversible engine are operating between temperatures T1 and T2. Okay. T2 and T3. Very good. T2 and T3 इसका मतलब they are connected in series. T3 and T4 and yes T1 T2 T2 T3 and T3 and T4 तीन इंजन्स they are connected in series with each other and the temperatures of source and sink respectively are T1 T2 T2 T3 and T3 T4 with 1 Kelvin difference in their temperature. Source और sink के temperature में there is always a difference of 1 Kelvin and they are all having the efficiency eta 1, eta 2 and eta 3. What is the relation between eta 1, eta 2 and eta 3? चलिए सॉल्व करते हैं. Everybody please give it a try. पहला इंजन T1 is the source temperature. There is an engine E1 and T2 is the sink temperature. There is a work produced W1. दूसरा जो इंजन है रिवर्सिबल इंजन is working between T2 and T3 और जो तीसरा इंजन है E3 that is working between T3 and T4. This is how the diagram will be. So what is the thermal efficiency of an engine? The thermal efficiency is given by the work output upon heat input. What will be the thermal efficiency? Net work output upon heat supplied. अब अगर हर थर्मल रिजर्वायर के बीच में 1 केल्विन का टेम्परेचर डिफरेंस है एंड इफ द साइकिल इज रिवर्सिबल देन द थर्मल एफिशिएंसी ऑफ ए रिवर्सिबल इंजन कैन बी रिटन इन टर्म्स ऑफ टेम्परेचर्स. कैसे होगा? 1 माइनस टेम्परेचर ऑफ द सिंक टू द टेम्परेचर ऑफ द सोर्स. होगा कि नहीं? डू यू गाइज रिमेंबर दिस फॉर्मूला? यस और नो? फर्स्ट के लिए होगा 1 माइनस T2 by T1. सेकेंड थर्मल एफिशिएंसी 1 इज इक्वल टू 1 माइनस T2 by T1. एफिशिएंसी फॉर द engine 2 will be equal to 1 minus T3 by T2 and efficiency for the third engine will be equal to 1 minus T4 by T3 because all are reversible engines. Carnot engine का मतलब है they are reversible. सबसे सिंपल तरीका इस क्वेश्चन को सॉल्व करने का क्या होगा कि अगर 1 केल्विन टेम्परेचर डिफरेंस है, राइट? सो अगर मैं T4 को 1 केल्विन अज्यूम करता हूं, इफ आई अज्यूम टेम्परेचर ऑफ द सिंक फॉर द थर्ड इंजन दैट इज 1 केल्विन, तो T3 की वैल्यू 2 केल्विन होगी, T2 की वैल्यू 3 केल्विन होगी एंड T1 विल कम आउट टू बी 4 केल्विन. न्यूमेरिकल वैल्यू अज्यूम कर लीजिए 1 केल्विन डिफरेंस के हिसाब से एंड देन व्हाट वी कैन से, if I say thermal efficiency for the thermal efficiency for the engine 1, then what will be the answer? For engine 1, thermal efficiency for the engine 1 क्या होगा? 1 minus T2 by T1, 3 by 4. Efficiency of 2 होगा 1 minus T3 by T2 that is 2 by 3 and thermal efficiency for the third engine will be 1 minus 1 by 2. ये 0.5 आ जाएगा, ये 0.25 आ जाएगा, ये भी वैल्यू कुछ ना कुछ 0.5 और 0.25 के बीच में 1 by 3 आ जाएगा 0.33. सो यहां से वी कैन इजिली से थर्मल एफिशिएंसी 1 विल बी मिनिमम, देन 2, देन 3. कई बार क्वेश्चंस में न्यूमेरिकल वैल्यू पुट करके सॉल्व किया जा सकता है. दैट इज व्हाट इज द लर्निंग फ्रॉम दिस पर्टिकुलर क्वेश्चन. आई होप इट इज क्लियर. Is this all clear to everyone? So the correct option is option B. Is this clear? Give me yes, everybody. क्या समझ में आया क्वेश्चन आप लोगों को? If you have any doubt, anything to ask, please do write in the comment section so that we can discuss the question again. Right? अगले क्वेश्चन पे चलते हैं. द नेक्स्ट वन इज द नेक्स्ट क्वेश्चन अगेन फ्रॉम द थर्मोडायनेमिक्स. 1 kg mass of air. Air can be treated as an ideal gas. You all know. Ideal gas assume कर सकते हैं इसको. The mass of the air is 1 kg. Right? expands reversibly from 65 bar and 0.0135 meter cube to a final volume of 0.1. Initial pressure is 65 bar. Initial volume is 0.0135 meter cube. Simple question है. And the final volume V2 is equal to 0.1 meter cube. Polytropically with polytropic index is 1.3. The change in internal energy is, what will be the change in internal energy? कैसे सॉल्व करेंगे? For change in internal energy, if the system is an ideal gas, so change in internal energy is m into cv into delta t, और change in enthalpy होता delta h की वैल्यू होती m into cp into delta t for an ideal gas, because ideal gas के लिए u and u is a function of temperature only. For an ideal gas, u will be a function of temperature only. U is given by mcv delta t. यहां से क्वेश्चन सॉल्व हो जाएगा. Can you do it? Mass is already given. Cv for air we know. क्या होता है Cv? 0.718. Cv की वैल्यू 0.718 किलो जूल पर केजी केल्विन. यही होती है Cv की वैल्यू. Yes or no? And delta T is final temperature minus initial temperature. तो हमें टेम्परेचर्स की वैल्यू चाहिए. इन द क्वेश्चन वी वांट द वैल्यू ऑफ टेम्परेचर्स. फाइंड आउट कर सकते हैं. सो डेल्टा यू इज इक्वल टू, ऑप्शंस आर इन किलो जूल, ऑल द ऑप्शंस आर इन किलो जूल. एम इज 1 इंटू 0.718 इंटू T2 माइनस T1. अब हमारा ऑब्जेक्टिव है T2 और T1 की वैल्यूज फाइंड आउट करना. T1 तो यहां से मिल सकता है. T1 कैसे मिलेगा? P1 V1 is equal to MR T1. So from here T1 will be equal to P1 V1 upon M into R. Pressure at 1 क्या है? 65 बार. 65 into 100 किलो पास्कल. 1 बार is equal to 10 to the power 5 पास्कल और 100 किलो पास्कल into V1. वॉल्यूम 1 क्या है? 0.0135. 0.0135. M1 R कितना होता है? 0.287. What is the value of R? R will be equal to 0.287 kilojoule per kg Kelvin. So the temperature T1 will come out to be, what is the value of T1? Are you getting 305.8 Kelvin? Please do let me know. क्या आप सॉल्व कर सकते हैं? डेफिनेटली सॉल्व कर सकते हैं. यू जस्ट हैव टू पुट द वैल्यूज ओनली इन द गिवन. यू हैव टू कैलकुलेट द गिवन एक्सप्रेशन. मैंने 0.287 किलो जूल पर केजी केल्विन में लिया, तो इसलिए मैंने ये भी किलो पास्कल में लिया हुआ है. राइट? कितना होगा? 6500. एक बार चेक कर लेते हैं क्विकली. 0.0135 एंड डिवाइड बाई 0.287. 305.749. Isn't it? अब T2 कैसे निकलेगा? Because the process 1 to 2 is polytropic. 1 to 2 कैसी प्रोसेस है? पॉलीट्रॉपिक. PV to the power n is constant. ये होता है पॉलीट्रॉपिक प्रोसेस. और यहां से T2 by T1 is equal to V1 by V2 to the power n minus 1 से T2 की वैल्यू फाइंड आउट कर सकते हैं. T2 is equal to T1. T1 हमने ऑलरेडी कैलकुलेट कर लिया. 305.8. V1 by V2 both are given 0.0135 upon 0.01. 0.1 है क्या? Yes, 0.1 to the power n minus 1. n is 1.3. n is 1.3 minus 1. क्या वैल्यू आएगी? What is the value of T2? What will be the value of T2? 0.0135 divided by 0.1 to the power 0.3 into 305.8. कितना आ रहा है? How much is the answer? 0.0135 डिवाइड बाई 0.1, थोड़ा सा गड़बड़ हो गया, डिवाइड बाई टू द पावर 0.3 इंटू 305.8. Are you getting 167.7? Yes or no? Are you guys getting 167.7 केल्विन? बताइए. T2 की वैल्यू होगी 167.7 केल्विन. T1 की वैल्यू ऑलरेडी हमने कैलकुलेट कर ली है, दैट इज 305. बिकॉज T2 इज लेस देन T1, द आंसर शुड बी नेगेटिव, और इसी वजह से देयर इज ऑलवेज ए डिक्रीज इन इंटरनल एनर्जी. दैट इज वाई द ऑप्शंस आर गिवन इन 1 into 0.718. T2 is 167.7 minus 305.8. Our answer will be in kilojoule. The answer will be in kilojoule. Solve कर सकते हैं? बताइए quickly. 305.8 into 0.718. Very good. And your answer will be minus 99.15. Minus 99.15 will be the correct answer. Option B is the right answer for this one. Did you understand this? बताइए. Is there any doubt? Is there any confusion? If you have, please do let me know. Otherwise, let us move to the next one. Question number 3. Again, simple question. The question is from the change in entropy. बहुत लोगों को एंट्रोपी चेंज को लेके बड़ा कंफ्यूजन होता है. ब्यूटीफुल क्वेश्चन. एंट्रोपी चेंज को लेके एंट्रोपी चेंज फाइंड आउट करने में बहुत स्टूडेंट्स को डर लगता है, और बट क्वेश्चंस नॉर्मली सिंपल फ्रेम होते हैं फ्रॉम द एंट्रोपी चेंज. द क्वेश्चन इज 1 kilogram of a steel block. Okay, there is a steel block of 1 kg mass which is at a temperature of 1000 degrees Celsius, and this steel block is placed in contact with 2 kg of ice at 0 degrees Celsius. The temperature of the ice is 0 degree Celsius, और स्टील ब्लॉक को आइस के कांटेक्ट में लेके आए इन एन इंसुलेटेड कंटेनर. इसका मतलब देयर इज नो हीट लॉस टू द सराउंडिंग. जो भी स्टील ब्लॉक ने हीट लॉस किया होगा वो सारी की सारी हीट गेन की होगी आइस क्यूब ने, राइट. लेटेंट हीट ऑफ द फ्यूजन ऑफ वाटर इज, लेटेंट हीट ऑफ फ्यूजन क्या होता है? द heat required for 1 kg of mass of ice getting converted completely into water, that is given as 333.4 kilojoule per kg. And specific heat capacity of the steel, ये क्या है? joule per kg Kelvin is the specific heat. Specific heat for steel, Cp for the steel block is given as this. What will be the change in entropy of the ice? तो सबसे पहले क्वेश्चन को पढ़ के यह समझ में आता है कि इफ द हीटेड ब्लॉक इज ब्रॉट इन कॉन्टेक्ट विद द आइस क्यूब और आइस 2 kg of ice, then what will happen? The heat always flow from high temperature to low temperature. Ice is at 0 degree Celsius, steel block is at 1000 degree Celsius, then the heat will start flowing from the steel block to the ice. और उससे क्या होगा? द आइस विल स्टार्ट गेटिंग मेल्टेड, द आइस विल स्टार्ट मेल्टिंग. अब हमें यह देखना है कि हीट कितना सप्लाई किया स्टील ब्लॉक ने, एंड इज दैट हीट सफिशिएंट फॉर कंप्लीट कन्वर्जन ऑफ आइस इनटू वाटर, और द हीट इज लेसर देन द कंप्लीट कन्वर्जन ऑफ आइस इनटू वाटर, और द हीट सप्लाइड इज मोर then the complete conversion of ice into water. Agar heat supplied by the steel block is more than the heat required for complete conversion of ice into water, तो क्या होगा? After the ice completely getting converted into water, the extra heat will heat the water beyond 0 degree Celsius. तो water जो है उसका final temperature वो 0 नहीं होगा. तो सबसे पहले the first step is, let us find out heat required for complete conversion of water into ice. Sorry, complete conversion of ice into water. Ice into water. Ice कितना है? 2 kg. 2 kg आइस को अगर वाटर में कन्वर्ट करना है तो Q रिक्वायर्ड कितना होगा? व्हाट इज द हीट रिक्वायर्ड? कैसे फाइंड आउट करेंगे? 1 kg आइस को अगर वाटर में कन्वर्ट करना होता है तो द हीट रिक्वायर्ड विल बी 334.4 किलो जूल. सो Q रिक्वायर्ड विल बी इक्वल टू 2 kg into 333.4 kilojoule. So the heat required will be equal to 666.4 kilojoule. इतना चाहिए था. अब अगर हम अज्यूम कर लेते हैं कि द फाइनल टेम्परेचर ऑफ वाटर इज स्टिल 0 डिग्री, मीन्स देर इज ए कन्वर्जन ऑफ वाटर इंटू आइस इंटू वाटर. सो अज्यूम द फाइनल टेम्परेचर, assume equilibrium temperature is equal to 0 degree Celsius. That is temperature of water is equal to temperature of final temperature of water and final temperature of steel. ये हमने assume किया क्योंकि हमें नहीं पता कि what is the final temperature. अगर ये assume करके we find out how much is the heat lost by the steel block. So what is the heat lost by steel block? What will be the heat lost by the steel block? Can you find it out? The heat lost by the steel block, mass of the steel block into specific heat of the steel block into delta T, initial temperature of the steel minus final temperature of the steel, isn't it? So mass of the steel is 1 kg. Specific heat of the steel is 0.5 kilojoule per kg Kelvin, 0.5. Initial temperature is 1000, final temperature is 0. So that will be equal to 500 kilojoule. So that is the amount of heat lost. अब ध्यान दीजिए कि heat lost by the steel block is 500 and heat required for the complete conversion of ice into water will be 666.4 kilojoule. Because the heat lost is less than heat required for complete conversion. Conversion of ice into water. होगा कि नहीं? बताइए. Do you agree or not? Give me yes. Everybody please give me yes if you agree. स्टील ने 500 किलोजूल हीट दी. अगर हम अज्यूम करते हैं, दैट इज माई अजम्पशन, इफ वी अज्यूम द फाइनल इक्विलिब्रियम टेम्परेचर ऑफ द स्टील ब्लॉक एंड द वाटर इज 0 डिग्री सेल्सियस, तो उस सिचुएशन में द अमाउंट ऑफ हीट विच इज गिवन बाय द स्टील टू आइस इज इक्वल टू 500 किलोजूल और कंप्लीट कन्वर्जन के लिए हीट चाहिए थी 666.8 किलोजूल. इट मींस there is a partial conversion of ice into water, isn't it? There is a partial conversion of ice into water. अगर heat supplied ज्यादा होती complete conversion से, then the final temperature would not have been 0 degree Celsius. जब तक हम बोल सकते हैं as long as heat lost is less than equal to heat required, then the final temperature or the final equilibrium temperature will remain 0 degree Celsius. क्योंकि phase change, when there is a phase change of the solid into liquid, there is no change in the temperature. The final temperature becomes 0 degree Celsius. और अगर heat lost by the steel block becomes more than the heat required, then the final temperature of water will definitely be greater than 0 degree. और वही फाइनल टेम्परेचर स्टील का भी होता. बट यहां पे क्वेश्चन सिंपल हो गया बिकॉज द हीट लॉस्ट इज स्टिल लेसर देन द हीट रिक्वायर्ड. सो हम बोल सकते हैं देयर इज ए पार्शियल कन्वर्जन ऑफ आइस इनटू वाटर. So there is a phase change, and now because it is undergoing a phase change only, because it is undergoing, the ice is undergoing a phase change only, then the change in entropy for the ice will be equal to Q supplied, Q given upon temperature of the ice, Q by T. What is the heat supplied? that is equal to 500 kilojoule, and divide by what is the temperature, that is 0 plus 273 Kelvin. Isn't it? That is the temperature. Do you understand it or not? So that the heat is given is 500 kilojoule, and this will be the answer. 500 by 273 will be the change in entropy for the ice block. 500 divided by 273. अगर किसी को कोई डाउट है, please do let me know. It is 1.831 kilojoule per Kelvin. 1.831 kilojoule per kg Kelvin will be the final answer. क्वेश्चन और भी कॉम्प्लिकेटेड हो सकता था. कैसे? अगर द हीट सप्लाइड इज मोर देन 666 किलो जूल, अगर ऐसा होता तो उस केस में हमें फाइनल टेम्परेचर फाइंड आउट करना पड़ता. कैसे? 666.4 तो कंप्लीट कन्वर्जन ऑफ आइस इनटू वाटर में यूटिलाइज हो जाती. मान लीजिए द हीट सप्लाइड इज 1000 किलो जूल, तो 666 इसमें चली जाती. बची कितनी? 333 kilojoule would have increases the temperature of water from 0 to final temperature. So mass of water into specific heat of water, that is 4.18, into final temperature of water, that is unknown, minus 0 was the initial temperature. यहां is equal to 333 kilojoule. वहां से final temperature of water आता, और final temperature of water आने के बाद the change in entropy would have been calculated in two stages, two steps. पहला स्टेप क्या होता? Q means 666.4 divided by 273 plus mass of water into Cp for water into natural log of final temperature of water upon initial temperature, that is 0 degree. Whenever there is a phase change, then the temperature remains constant. उस केस में change in entropy is calculated by simply Q by T. अगर टेम्परेचर चेंज हो रहा होता तो the change in entropy is calculated by mc ln of T2 by T1. I hope this is clear. If Q lost would have been greater than Q required, तब क्या होता? For an example, ये 1000 किलोजूल and ये 666 किलोजूल. So हम बोलते change in entropy for ice, यहां से 333 kilojoule would have been mass of water 2 into 4.18 into T final minus 0. ये होता, और ये भी फिर चेंज होता. Q लॉस्ट कैसे निकालते? Q लॉस्ट निकालते मास ऑफ स्टील इंटू यहां से T फाइनल मिलता, मास ऑफ स्टील इंटू C of steel into delta T is equal to, यहां से कैलकुलेट करते, और उसके बाद चेंज इन एंट्रोपी फॉर द आइस विल बी इक्वल टू Q required for complete conversion upon T plus M into M for water, Cp for water into ln of T final by T initial. This would have been change in entropy for the ice. This would have been the change in entropy for the ice. कर सकते हैं ऐसा? अगर कोई डाउट होगा तो just write me in the comment section. And please guys, do not forget to like and share. Let us move to the next question. The next question. अगला क्वेश्चन क्या कहता है? In an Otto cycle, question number 4. In an Otto cycle, the temperature at the end of the heat supply. Otto cycle क्या होता है? Otto cycle is used in IC engine, that is constant volume cycle. Constant volume cycle. Volume must remain constant. The temperature at the end of the heat supply is this. अगर मैं TS डायग्राम बनाता हूं ऑटो साइकिल के लिए, टेम्परेचर वर्सेस एंट्रोपी, 1 to 2 is isentropic compression, 2 to 3 is constant volume heat addition, 3 to 4 is isentropic expansion, and 4 to 1 is constant volume heat rejection. 1 2 3 4 clockwise cycle, that is work producing cycle. यहां पे हीट सप्लाई होगा QS एट कांस्टेंट वॉल्यूम, यहां पे हीट रिजेक्ट होगा QR एट कांस्टेंट वॉल्यूम, वर्क आउटपुट WT एंड देयर इज ए कंप्रेशन वर्क WC. ये in an Otto cycle the temperature at the end of the heat supply is 0.3. So T3 is given as 3196.2 Kelvin, right? And at the beginning of the heat rejection यहाँ हो रहा है QS QR, beginning of the heat rejection is T4 is equal to 1391.3 Kelvin. Then what will be the thermal efficiency of the cycle? Can you find out the thermal efficiency of the cycle? Thermal efficiency of the Otto cycle is given by 1 minus 1 upon R to the power gamma minus 1 by gamma minus 1. For an Otto cycle, thermal efficiency is given by this. And we know T2 by T1, 1 to 2 is isentropic and 3 to 4 is isentropic. T3 by T4 is equal to R to the power gamma minus 1. T2 by T1 is equal to T3. R is equal to compression ratio. Volume before compression upon volume after compression. V1 by V2 to the power gamma minus 1. Isn't it? Yeah. So T2 by T3 by T4 can be replaced in place of R to the power gamma minus 1. So 1 minus 1 upon T3 by T4. So thermal efficiency of Otto cycle is 1 minus 1 upon T3 by T4, or we can write it as 1 minus T4 by T3. Value put कर दीजिए, you will get your answer in percentage. 1 minus what is T4? T4 is 1391.3, 1391.3, right? And what is T3? 3196.2, 3196.2. Solve करिए into 100. What will be the answer in percentage? Can you do it? Can you guys do it? 1391.3 divide by 3196.2 and 1 minus this answer into 100 will be 56.47%. The thermal efficiency of the Otto cycle is 56.47%. Right? Is this clear? बताइए, डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन है, इजीली कर सकते हैं. Question number 5. Again from the This is from the power plant engineering. पिछला क्वेश्चन आईसी इंजन से था, अभी ये क्वेश्चन पावर प्लांट से. In an ideal gas turbine plant, the inlet temperature, ideal gas turbine plant works on, कौन से साइकिल पे वर्क करता है? Quickly, which is the thermodynamic cycle on which ideal gas turbine works? What is that cycle? Thermodynamic cycle. It works on Brayton cycle. कौन सी साइकिल होगी? Yes, Shiva. It works on Brayton cycle. Well done. Brayton cycle को constant pressure cycle भी बोलते हैं. It is also known as constant pressure cycle. Okay. Inlet temperature is 300 Kelvin. अगर इसके लिए भी if we draw temperature versus entropy diagram, 1 to 2 is isentropic compression, similar to Otto cycle. 2 to 3 is constant pressure heat addition, and 3 to 4 is again isentropic expansion, and 4 to 1 is constant pressure heat rejection. This is P1, this is P2. This is constant pressure heat rejection. This is how the Brayton cycle looks like. The inlet temperature is the temperature at inlet to the compressor. T1 is given as 300 Kelvin. Peak temperature, the maximum temperature is T3. T3 is given as 1200 Kelvin, and the temperature drop in the turbine. What is the meaning of temperature drop in the turbine? Turbine is a work producing device. So 3 to 4 process is happening in the turbine, and there is a drop in temperature. So it is given as T3 minus T4 is 480.4 480.8 Kelvin. What will be the compression work? This is the compression work. 1 to 2 is compression work. So from steady flow energy equation, all are steady flow devices. For the steady flow devices, compressor is a steady flow device. So for a steady flow device, there is no change in, there is no heat transfer, and W is given by H. Work done, compression work is H2 minus H1, and it is an ideal gas. For an ideal gas, H is a function of temperature only. So we can write it as Cp into T2 minus T1. That is the compression work per kg. Cp into T2 minus T1. And Cp is already given 1.0035. The question is to find out T2 and T1. How to find out T2 and T1? T1 is known, T2 हमें find out करना है. The objective is to find out T2. How to find out the value of T2? कर सकते हैं? Please give it a try, everybody. Cp is given है, T1 पता है, the objective is to find out T2. Now to find out T2, as we know, T2 by T1 is equal to T3 by T4 is equal to Rp to the power gamma minus 1 by gamma. What is Rp? That is P2 by P1 to the power gamma minus 1 by gamma. 1 to 2 and 3 to 4 both are isentropic process. Both are isentropic. So from here we can find out T2 is equal to, सबसे पहले हमें T4 भी चाहिए, T3 minus T4 is 480. From here we can find out T4. From here we can find out T4. कैसे? How to find out T4? T4 is equal to T3 minus 480.8 Kelvin, right? So T3 is already known to us, 1200 minus 480.8, that is T4. The value of T4 is equal to 1200, very good, minus 480.8, which comes out to be 719.2 Kelvin. All right, 719.2 Kelvin is the value of T4. Now T2 is equal to T1 T3 upon T4. What is T1? Which is given as 300. Okay, and what is T3? Which is also given as 1200, and T4 we have already calculated 719.2. 719.2. So find out the value of T2 and put in the above equation. 300 into 1200 divided by this 500.55 Kelvin. Are you getting T2 as 550 Kelvin? 500 Kelvin. Are you getting T2 as 500.5 Kelvin? And then W compression, it is specific work. Compression work is given by Cp 1.0035 into T2 500.55 minus T1, that is 300, that will be in kilojoule per kg. Do the calculation and find out the answer. Do the calculation and find out the answer. 201.26, 201.26 kilojoule per kg will be the answer. 201.25 or 26. C is the right answer for question number 5. Is this clear? All set? कुछ confusion, कोई doubt? Beautiful question it is. Question number 6. इस क्वेश्चन का जो जवाब देगा, it means your concepts are very much clear for the thermodynamics. You are fully ready for cracking the BARC 2024 examination. Let us read the question, try to understand it and give the answer. The PV diagram for two expansion processes. Expansion means volume increases, and if there is an increase in volume, pressure will decrease because of ideal gas equation. The PV diagram is given. This is the PV diagram, pressure versus volume diagram for two expansion processes. There are two processes. Both are having increase in volume and decrease in pressure are shown in the figure, where N represents the polytropic index. For process 1, let me call it as process 1, the polytropic index is 1.5, and let me call it as process 2, polytropic process 2, the value of polytropic index is 1.2. The TS diagram for these two processes will be, we have to draw the temperature versus entropy diagram for this. Agar, look, PV to the power n is constant if the expression is, then we can say for n greater than 1. If n is greater than 1, it can be polytropic index, it can be adiabatic index. For n to be greater than 1, if there is a decrease in pressure, there is an increase in volume and there will be a decrease in temperature. Yes or no? If there is an increase in pressure, there is a decrease in volume and there will be an increase in temperature. तो अगर प्रेशर डिक्रीज कर रहा है दोनों प्रोसेस के लिए तो टेम्परेचर भी डेफिनेटली डिक्रीज करेगा. टेम्परेचर विल डिक्रीज फॉर बोथ द प्रोसेसेस. अगर प्रेशर डिक्रीज कर रहा है तो देयर विल बी ए डिक्रीज इन टेम्परेचर. सो टीएस डायग्राम में द टेम्परेचर फॉर बोथ द प्रोसेस मस्ट डिक्रीज 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 डिक्रीज. वी आर नॉट गेटिंग एनीथिंग फ्रॉम हियर. एंट्रोपी पे क्या असर पड़ेगा? अगर टेम्परेचर डिक्रीज कर रहा है तो dt विल बी नेगेटिव. यस और नो? अगर टेम्परेचर डिक्रीज कर रहा है प्रोसेसेस के लिए बिकॉज n इज ग्रेटर देन 1, तो टेम्परेचर विल डिक्रीज and the temperature is decreasing, the change in temperature, that is final minus initial, will be negative. It will be negative. Yes or no? Now let us try to find out the entropy. Entropy change is calculated from the heat transfer. Heat always carries the entropy. Heat added to the system will increase the entropy of the system. Heat decreases from the system or heat given out from the system will decrease its entropy. Heat given to the system increases the entropy. Heat rejected from the system will decrease the entropy of the system. So what is the heat transfer for the polytropic process? Mass into C for the polytropic process into delta T. Isn't it? MC delta T. dt, or we can say delta T is negative. This is negative. What is C poly? Where C specific heat for a polytropic process is n minus gamma upon n minus 1 into Cv. That is for the polytropic process. N minus gamma upon n minus 1 into Cv. Yes. So हमें ये चेक करना है whether Q polytropic is positive or negative. If Q polytropic is positive, if Q polytropic is positive, then delta S will be positive. Or if Q for a polytropic process is negative, then delta S will also be negative. Yes or no? तो क्योंकि डेल्टा टी ऑलरेडी नेगेटिव है, नाउ इट विल बी डिसाइडेड बाय सी पॉली. सी फॉर ए पॉलीट्रॉपिक प्रोसेस, वी नो सी फॉर ए पॉलीट्रॉपिक प्रोसेस n माइनस गामा अपॉन n माइनस 1, वेयर gamma is equal to 1.4. Adiabatic index is 1.4. Now for a process 1, try to understand, this is 1. For 1, n is equal to 1.5, which is greater than gamma. N is 1.5, which is greater than gamma. So C poly will be positive. If C for a polytropic process is positive, then Q for a polytropic is negative. Why? Because delta T is negative. So Q is negative, so it means entropy will decrease, S1 will decrease. For process 2, N is equal to 1.2, which is less than gamma. For process 2, N is less than gamma, so it means C poly will be negative and delta T is already negative. We have already seen delta T is negative. So C भी negative हो गया, delta T भी negative हो गया, so Q poly will become positive. Q poly will become positive. If Q poly will become positive, then entropy will increase. For the process 2, entropy will increase, temperature will decrease. Temperature will decrease and entropy. For process 1, entropy will decrease and temperature will also decrease. For process 2, entropy will increase and temperature will decrease. अगर इनको चेक करें, for the process 1, temperature is decreasing, entropy is increasing. For process 1, entropy और temperature दोनों decrease करना चाहिए था. For process 1, entropy and temperature both should have decreased. So this is not possible. This is process 1. Entropy increase कर रहा है, not possible. This is 1. Entropy decrease कर रहा है, temperature भी decrease कर रहा है. This is possible. But if we talk about process 2, so entropy must increase, but the temperature must decrease. If we talk about process 2, entropy must increase, temperature must decrease. So that is why it is not possible. So this is process 1 and this is process 2. Entropy will increase for 2, S2 will increase and T2 will decrease. S1 will decrease and T1 will decrease. So D is the correct answer for this one. D will be the right answer for this one. Do you guys understand this question or not? बताइए. If anybody is having any doubt, anything to ask, please do let me know. All fine with everyone? Is it all fine with everyone? बताइए. Are you able to understand this? Let us move to the next one. One more question from the thermodynamics. Then we will move to the fluid mechanics. Then we will discuss some questions from the fluid mechanics. Question number 7. The work of, read the question and try to solve it. The question is, हाँ कैसे करेंगे शिवा? हाउ? dt by ds फाइंड आउट करेंगे ना? Can you get the answer? Can you obtain option D? How you are going to obtain option D? If you will use the slope concept. For the process 1, you have to find out. For the process 1, temperature will decrease and entropy will also decrease. For the process 1, temperature must decrease and entropy must decrease. It means slope is positive. Slope is positive, right? For the process 2, temperature is decreasing but entropy will increase. So the slope is negative. Yes, that is what we can do. But for that you need to find out these two relations. Yes. Look, slope क्या कहता है? dy by dx is the slope. If x increases and y increases, or if x decreases and y decreases, then the slope is positive. Then the slope is positive. And how the slope is negative? By increasing x if y is decreasing, or by decreasing x if y is increasing, then the slope will be negative. Then it means the slope will be negative. So for the first process, slope of TS curve will be positive. For the second curve on the TS diagram, the slope will be negative. यहां पे इसका भी स्लोप, फर्स्ट का भी स्लोप नेगेटिव है, फर्स्ट का भी स्लोप नेगेटिव है, सेकंड का भी स्लोप नेगेटिव है. So that cannot be true. Here this is having negative slope, this is also having negative slope. Not possible. In this, first will having negative slope, slope is negative. This is having positive slope. Second is having positive slope, first is having negative slope. That is why it is not true. It should have been opposite. The third case, the third figure says first curve is having a positive slope, second curve is also having a positive slope. That is why it is not correct. The final figure, the slope of first is positive and the slope of second curve is negative. Negative. And that is why option D is correct. Are you getting it, Shiva? That is how you can use the concept of the slope. But you need to get this relationship first, and that is obtained by from the ideal gas equation and the polytropic ideal gas equation for a polytropic process. So the temperature will decrease because there is a decrease in pressure. So delta T is negative. There is a decrease in temperature, and then we need to apply the heat transfer rate for a polytropic process, where the specific heat for a polytropic process is given by N minus gamma. It can be positive, it can be negative. The specific heat for a polytropic process can have a positive value, it can have a negative value. So if N is greater than gamma, then C will be positive. If N is less than gamma, then C will be negative. So from here we can find out Q for a polytropic process, and based on that we can find out the change in entropy, whether it is negative or positive. I hope this is clear, Shiva. Is this all fine now? Let us move to the next one. This is how the questions are going to be asked. You need to read the question carefully and then apply the concept to get the final answer. Agla question. The work of 146 kilojoule is performed in order to compress 1 kilomole of the gas. The work is done on the system. As the language suggests, the work is done on the system. कितना वर्क किया गया है? 146 kilojoule. So W is negative, isn't it? Work done on the system is negative. In order to compress, compression work is always negative. In order to compress 1 kilomole of the gas, the number of moles is 1 kilomole. N is equal to 1 kilomole. Adiabatically, what is the adiabatic process? Q is equal to 0. There is no heat transfer, thermally insulated system. And in the process, the temperature of the gas increases by 7 degrees Celsius, or we can also call it as 7 Kelvin. The gas is the universal gas constant. This is R bar. R is the universal. They must have mentioned it. It is universal gas constant 8.314. This is the universal gas constant 8.3 joule per mole Kelvin, or we can call it as 8.3 kilojoule per kilomole Kelvin. So ये gas monoatomic, diatomic, triatomic. Gamma for monoatomic 5/3. What is 5/3? Gamma for monoatomic, that is 1.66. Gamma for diatomic 7/5, that is 1.4. Gamma for polyatomic, that is 4/3, that is 1.33. So we need to find out the value of gamma. The question is to calculate the value of adiabatic index for the given system. So if we apply first law, because work done is given and heat transfer is also given, so according to first law, Q is equal to delta U plus W. Q is equal to 0. So delta U is equal to minus W, and W is already negative, that is minus of minus 146 kilojoule. So delta U is equal to 146 kilojoule. So delta U is equal to 146 kilojoule is equal to M into CV into delta T. Can we write MCV delta T? क्योंकि number of moles given है, so mass is equal to M by molecular weight is equal to number of moles. So M is equal to 146 kilojoule is equal to N into molecular weight. What is CV? CV is equal to R upon gamma minus 1 into delta T. Yes or no? And what is R? Can we write R? So it can be written as N into M into R can be written as R bar by M into gamma minus 1 into delta T. R is equal to R bar by M. R bar is universal gas constant, capital M is the molecular weight or molar mass. So this M will get cancelled out with this M. So 146 is equal to 1 is the number of kilomole into R bar is given as 8.3 kilojoule per kilomole Kelvin. Delta T is given as 7 upon gamma minus 1. Can you do the calculation? This kilomole getting cancelled out, and kilojoule will also get cancelled out. This is Kelvin get cancelled out. So gamma minus 1 is equal to 7 into 8.3 upon 146, or we can find out the value of gamma. What is the value of gamma? Can you calculate the value of gamma? 7 into 8.3 divide by 146. Very well done. That is 0.39 plus 1, 1.39. It is almost 1.4. So it is 7 by 5. So gamma is almost 7 by 5. कौन सी गैस होगी? Isn't it diatomic? Isn't it diatomic? Shiva, won't it be diatomic gas? Yes or no? Monoatomic कैसे हो जाएगा? You must get gamma to be around 1.4. If you are getting 1.4, then it must have been diatomic, right? Yes, for 1.4 it is. So सबसे पहले क्वेश्चन को पढ़ के ये समझ में आना चाहिए, how to find out whether it is monoatomic, diatomic or triatomic. The value of gamma decide, the value of adiabatic index or specific heat ratio decide whether the gas will be monoatomic, diatomic or polyatomic. So how to find out gamma? From the first law of thermodynamics, we can develop a relation between delta U and W, and W is given, so we can write delta U is equal to minus of W, and then delta U can also be written as MCB delta T for an ideal gas. Let us move to the fluid mechanics questions then quickly. If you are preparing for GATE 2025, we are running a series on our Byjus exam prep app, which is known as Ground Zero series for all the 5 branches, where we give you the understanding of the concepts from the basic till the advanced level. And today at 5:30 p.m. Today at 5:30 p.m. Today at 5:30 p.m. I will take fluid mechanics. Sorry, I will take heat transfer concept, not fluid mechanics. Fluid mechanics had been discussed in previous or in February month. So I will talk about conduction in the heat transfer. The topic will be conduction. So do not forget to join me at 5:30. If you want to be part of this session, do install our Byjus exam prep app if you have not installed it yet. And do not forget to join me at 5:30 sharp on the app, right? We will discuss all the beautiful concept in the simplest possible manner in this session. Next question, question number 8 from the fluid mechanics. Fluid mechanics, a 40 centimeter cubical block. The shape of the block is cube and the side of the block is 40 centimeter, slides on oil. Okay. Viscosity of the oil is 0.8 Pascal second. Unit से पता चलेगा, it is the dynamic viscosity or coefficient of viscosity or absolute viscosity is given. कई बार यूनिट मीटर स्क्वायर पर सेकेंड में भी दिया जाता है. So you should take care of the fact that if the unit is meter square per second or stock, then it must be the kinematic viscosity. And if the unit is Pascal second or dyne second per centimeter square or kg per meter second or poise, it means it is a dynamic viscosity mu. All right. Over a large plane horizontal surface, there is a horizontal surface, and there is a cubical block which is sliding over this. All right. And the gap is filled with an oil. Oil. Yes, this is an oil. If the oil film between the block and the surface has a uniform thickness of 0.4 mm, H is equal to 0.4 millimeter. The thickness is always in millimeter. What will be the force required to drag the block at 4 meter per second. The velocity of the block should be 4 meter per second. The question is very simple. Ignore the end effects and treat the flow as two-dimensional. If we apply Newton's law of viscosity, assuming the velocity profile to be linear, because it is not given, the velocity profile in the fluid is assumed to be linear. So shear stress, that is the force upon the shear area, is equal to mu into V by H. So force, tangential force required will be equal to mu 0.8 into area. Which area is the shear area? The contact area between the moving surface and the fluid. So 40 centimeter, the unit is centimeter. 0.4 into 0.4 into velocity of the fluid particles in contact with the moving surface, that is 4 meter per second, upon fluid thickness 0.4 into 10 to the power minus 3. That will give you the answer in Newton. 0.4 getting cancelled out. Can you do it? So 8 into 4 into 40, 10 to the power 3 चला जाएगा यहाँ पे. So it will be 8 into 4 into 40 Newton. कितना होगा? 160 into 8. 160 into 8 Newton. 1280 Newton. Well done, Shiva. Ravneet. Good. 1280. Great. The next question on your screen. Agla question. Try to solve this one. A nozzle has an inlet and outlet diameter. There is a nozzle. क्या होता है nozzle? Nozzle is a converging section. Inlet diameter, that is section 1. Outlet diameter, that is section 2. The flow is from 1 to 2. That is how the nozzle is designed. As an inlet and outlet diameters, D1 is given as 10 and D2 is 5. Diameter is decreasing. If it discharges air, the fluid is air. Density is 1.2 kg per meter cube. इसका मतलब the air is treated as incompressible. As long as the density is constant, the air will be treated as incompressible. At the rate of 0.1 meter cube per second, the flow rate is 0.1 into the atmosphere. The fluid is, the air is discharged into the atmosphere. What will be the gauge pressure, static gauge pressure at the nozzle inlet? We need to find out gauge pressure at 1. Can you do it? सबसे पहले if we apply the mass conservation equation, if we use the continuity equation, Q is equal to A1V1 is equal to A2V2, that remains constant. So we can say D1 square into V1 is equal to D2 square into V2, or D1 is given as 10, D2 is given as 5. So V2 will be equal to 4V1, and V1 can be calculated by 4Q by pi D1 square. We can find out V1 anytime. We can calculate V1. So V2 is equal to 4V1. That is our expression number 1. If we apply the Bernoulli equation between 1 and 2, in terms of flowing fluid, in terms of pressure, so we can say P1 plus rho V1 square by 2 plus rho G Z1 is equal to P2 plus rho V2 square by 2 plus rho G Z2. Yes or no? Because Z1 is equal to Z2. The pipe, the nozzle is horizontal. मेंशन नहीं कर रखा ना, हॉरिजॉन्टल इन्होंने मेंशन नहीं कर रखा, because the heights are not given, so we can assume them to be horizontal only. And if we put P1 and P2 as gauge pressure P2 gauge will be equal to 0 because the fluid is discharged into the atmosphere. So P1 gauge is equal to rho by 2 V2 square minus V1 square, or we can say rho by 2 V2 is equal to 4V1, 16 V1 square minus V1 square, so it will be 15 rho by 2 into V1 square, isn't it? 15 V1 square rho by 2. V1 को लिखा जा सकता है 4Q by pi D1 square. V1 को कैलकुलेट किया जा सकता है. What is V1? 4 into Q1 0.1 upon pi into d1 square. What is d1? d1 is 10 centimeter, 0.1 square. 0.1 getting cancelled out. So 4 upon 0.1 pi. 4 divided by 0.1 pi. 12.73. V1 is equal to 12.73 मीटर पर सेकेंड. ये वैल्यू यहां पे पुट कर दीजिए. So it is 15/2 into 1.2 into 12.73 whole square will give you the answer for gauge pressure at 1 into 7.5 into 1.2. 1459.025 पास्कल, और in kilo pascal 1.459 kilo pascal will be the answer. Yes, Ravneet, well done. The answer to this question is option B. B will be the correct answer. All right. Very nice. Good. Keep it up, everybody. The next question, question number 10. The next one is question number 10. Question says, consider incompressible flow, means density is treated as constant, all right, through a two-dimensional open channel at a certain section AA. This is the section AA. The velocity profile is given by this parabola. This is the parabolic velocity profile. Neglecting air resistance at the free surface. This is the free surface. And find the volume flow rate per unit width of the channel. Find the volume flow rate. Let me call the velocity is given by U and this is Y. So what we need to find out? We need to find out the discharge. Q is equal to area into velocity. Because V is variable. Because V is variable. So we can say Q is equal to integration of U into dA. Isn't it? U is a function of Y. U will be a function of Y. So at any Y, if we take dy element, so Q is equal to integration of U as a function of Y into dy, and the limit of Y will be from 0 to 2. 0 to 2. Yes or no? Can you do it? Now our objective is to develop a relation between U as a function of Y. Yahan students commit the mistake. If you see, this is a parabola like this. It is upward open parabola. ऊपर की तरफ खुला हुआ है. The parabola is something like this. It means Y is always positive. Here Y will always be positive. Right? Y will always be positive. So we can say Y is equal to A into U square is the expression of the parabola. Yes or no? This will be the expression of parabola. Y is equal to AX square and X is equal to U. The value of X is U. It is the curve between U and Y, not X and Y. So Y is equal to X square. This curve is Y is given by AX square. Right? Here people commit mistake. They start writing U is equal to AY square. That is incorrect. U is given by AY square. That is not correct. Y is given by AU square. So at Y is equal to 2, U is equal to 10 meter per second. So 2 is equal to A into 10 square. So what is the value of A? A is equal to 2 by 100, 1 by 50. So Y is equal to U square by 50. Yes or no? So Q is equal to integration, or from here U can be written as under root of 50Y. So U into dy, integration of under root of 50Y into dy, and the limit will be from 0 to 2, will give you the final answer. Isn't it? Can you do the calculation? Q is equal to under root of 50 is taken outside. Under root of y dy. What is the integration of y dy? Under root of y dy. तो सॉल्व कर सकते हैं. Under root of y to the power 1 by 2 plus 1, 3 by 2, y to the power 3 by 2 upon 3 by 2. So into 2 by 3 into 2 to the power 3 by 2. Can you solve it? And you will get the answer. 2 to the power 3 by 2, that is 1.5, multiplied by 2 multiplied by root 50 divided by 3, that is 40 divided by 3 meter cube per second, that is 13.33 meter cube per second will be the discharge. The question is simple. The only thing is you should be able to find out the expression for u as a function of y correctly. B is the right answer. All right, clear? चलिए क्वेश्चन नंबर 11 पढ़िए क्विकली. रीड द क्वेश्चन नंबर 11. Tomorrow at 11 we will be having complete mock test for BARC 2024, similar to your actual examination. So do not forget to revise the entire syllabus, and do not forget to attend the mock test, full length mock test for your BARC 2024 examination. All right. The question says water flows from an open vertical cylindrical tank. There is an open cylindrical vertical tank of 20 centimeter diameter. Diameter of the tank is 20 centimeter through a hole of 10 centimeter diameter. This is the hole. 10 centimeter का तो hole ही है. D is equal to 10 centimeter. It is not a hole. We should not call it as a hole, क्योंकि ये तो इसका तो diameter भी काफी है. What will be the velocity of water flowing out of the hole at the instant? The velocity of flow out of the hole at the instant when the water level in the tank is 50 meter. When the level of water in the tank H is equal to 50 meter above the hole. Ignore the unsteady facts. Now, how many of you think that it will be given by under root of 2gh? Torsional equation. How many of you think it is given by root 2gh? The velocity from the hole will be root 2gh. जानबूझ के उन्होंने इक्वेशन में होल वर्ड यूज किया है. इट इज द डायमीटर्स आर वेरी मच कंपेरेबल. स्मॉल डी इज हाफ ऑफ कैपिटल डी. सो दिस इक्वेशन विल नॉट बी यूज्ड. दिस इक्वेशन, टॉर्सल इक्वेशन विल बी यूज्ड. वी यूज टॉर्सल इक्वेशन ओनली व्हेन a1 इज वेरी वेरी लार्ज कंपेयर टू a2. तभी v is equal to root 2gh यूज करेंगे, otherwise we will not use. So if we use the continuity equation, if we apply the continuity equation, here the velocity is, let us say v1, this is 0.1, here the velocity is v2, let us say this is 0.2. So if we apply the continuity equation, q is equal to a1 v1 is equal to a2 is equal to constant, because the flow is steady. So we can say d1 square into v1 is equal to d2 square into v2. And what is d1? Capital D 20, small d is 10, half. So v2 is again 4 times of v1. v2 is equal to 4 times of v1. And now if we apply the Bernoulli equation, if we apply the Bernoulli equation between 1 and 2, this is 1, this is 2, between 1 and 2. So we can say P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g. Z2 is equal to 0. Z1 is equal to H is equal to 50 meter. Z2 is 0. P1 and P2 is equal to P ATM, both are at atmosphere. So H is equal to H plus V1 square by 2G is equal to V2 square by 2G. So from here we can find out V2 square is equal to V1 square plus 2GH. V2 square is equal to V1 square plus 2GH, or we could have said V2 square minus V1 square. The expression would have been V2 square minus V1 square is equal to 2GH. Is equal to 2GH. It is not V2 square is equal to 2GH. It will be V2 square minus V1, because we cannot ignore the velocity at 1, because area is not very, very large. And what is V1? V1 is equal to V2 by 4. V1 is equal to V2 by 4. Can you do the calculation now? So from here, V2 square minus V2 is equal to V1 by 4. V1 is equal to V2 by 4. Put the value of V1, then V2 square by 16 is equal to 2GH, or we can say 15 V2 square by 16 is equal to 2GH. So V2 is equal to 16 into 2 into G, 9.81 into H by 15, and then under root. What is the answer? 32 into 9.81 into 50 and divide by 15, and do not forget to take square root. 32 3.23. Are you getting this? Why I am getting 50 centimeter है क्या? It is 50 centimeter, sorry. It is 50 centimeter. So 0.5. 3.234. Yes, Ravneet, well done. 3.23. 3.23? क्यों नहीं रहा? B will be treated as correct answer, because we have taken G as 9.81. If we take G as 10, then it will be 3.26. 3.26. If we put G as 10, then you will get 3.26, right? The next one, question number 12, from the pressure equation. Let us solve the next one. In the manometer shown in the figure, the pressure PA of the gas inside the bulb is approximately, the atmospheric pressure is given as 1 bar, and your answer should be in bar. 1 bar is equal to 100 kilopascal or 10 to the power 5 pascal. This should be the conversion factor. Because it is a gas, so the pressure normally does not vary in the gas, because the density of the gas is very, very small. Because of the very small density of the gas, so PA is the pressure here. If we write the pressure equation, these 2 points will have equal pressure. That is called as datum line. These 2 points will have equal pressure as per the Pascal's law. So how to write the pressure equation? Here the pressure is PA. We are traveling in downward direction. The pressure increases with depth. We are traveling in water. Density of water into G into how much is this distance? 30 minus 20. That is 10 centimeter. That is 0.1. Is equal to the outside pressure is P ATM. From here P ATM we are traveling in downward direction, plus now we are traveling in mercury into G into 30 centimeter, that is 0.3 meter. PA absolute is equal to P ATM is 1 bar, plus if you put them in, if you put the values in their SI unit, you will get Pascal. 13.6 into 10 into 0.3. So it will be 13.6 into 10 into 0.3, that is kilopascal upon 100 minus 1 into 10 into 0.1 upon 100, that will be bar. That will be bar. What is the answer? 1 plus 100 getting cancelled out. So 1.36 into 0.3, 1.36 into 0.3, 0.408 minus this 0 is getting cancelled out with this 0, minus 0.01 bar. This much will be your answer. So 1 plus 0.408 minus 0.01, 1.398, 1.398, almost 1.2 bar. Sorry, 1.39 ni, it is 1.398, that is almost 1.5 bar. That is 1.398 bar. Do not miss the units here. That will be the answer. Question number 13, wonderful question. Question number 13 on the screen. Consider a fully developed laminar flow. What is the meaning of laminar flow? Laminar flow given hai. When the Reynolds number is less than 2000, the flow is laminar, right? The flow is laminar for Reynolds number less than 2000, or laminar flow hota hai to friction factor is given by 64 by Reynolds number. We can use Hagen-Poiseuille equation. The maximum velocity is twice of average velocity. These are the things. If the diameter of the pipe is halved while the flow rate Q and length are constant, what will be the change in head loss? We need to find out the head loss as a function of diameter. So what will be the change in head loss if D2 becomes half of D1? Then HL2 by HL1 is how much? That is the question. So the question is to develop a relation between HL and diameter. For laminar flow, HL is given by FLQ square upon 12.1 D to the power 5. Discharge is constant, length is constant, 12.1 is constant. So we can say HL is proportional to F by D to the power 5. And F is equal to 64 mu upon rho Vd. Or we can say 64 upon mu is constant, this is constant. So from here we can write, F is inversely proportional to V into D. F is inversely proportional to V into D. And velocity is given by 4Q by pi D square. So Q is constant, velocity is inversely proportional to D square. If we put velocity here, 1 by D square, and if we put F here, then our expression will be, so from here we will get F is proportional to D square by D. So F is directly proportional to D. If we put it here, then HL is proportional to D upon D to the power 5. So HL is inversely proportional to D to the power 4. That is the final relation. Or if we could have used the Hagen-Poiseuille equation, HL is equal to delta PL by rho G. That is 1 by rho G. Delta PL is 32 mu VL by D square. So from here HL is rho is constant, G is constant, 32 constant, mu is constant, length is given constant, HL is proportional to V by D square, and V is equal to 4Q by pi D square. So we can say V is inversely proportional to D square. Put it here. So HL is inversely proportional to D to the power 4. Whether we use Hagen-Poiseuille equation or Darcy-Weisbach equation. Whether we use Darcy-Weisbach equation or Hagen-Poiseuille equation, you will get the same result. Do like this session, guys, so that other students can also watch this and get some practice before the BARC examination. So HL is, so the final expression is HL is universally proportional to D to the power 4. So HL2 upon HL1 is equal to D1 by D2 to the power 4. So D1 is twice of D2. So 2 to the power 4. 16 will be the answer. 16 will be the answer. C will be the correct answer, right? So we are also running the post-gate guidance session on our Byjus exam prep app. The session had already been started from 30th of Feb. The sessions are on our app. So if you have appeared for GATE 2024 and if you want to know what were the cutoffs previously and what you can get based on your GATE score, you do not forget to join these sessions where we discuss the cutoffs for various NITs, the cutoffs for various PSUs, etc. So it will help you to take the right decision for your future. All right. So now let us stop here only. There are few more questions, a couple of more questions from the heat transfer, but tomorrow we will be having full mock test on the Byjus YouTube channel only. So all the 4 faculties, Dheeraj sir, myself, Suraj sir and Vipin sir will be there, and we will solve or we will have the mock test for all the 100 questions in tomorrow's session. All right. So do not forget to join and do share this information to all your friends and colleagues who are sincerely preparing for BARC 2024. All right. And if you are preparing for 25 or 26, then we are running the paid courses. You can have a discussion with our counselor. If you are interested, give a call to the counselor, or you can just fill the form, counseling form. Our counselor will have one-to-one discussion with you regarding your preparation journey, regarding your career, and regarding the fee structure for our paid courses. All right. So with this note, let me take your leave. Thank you very much for being part of this session. I will see you at 5:30 today on the Byjus app for the heat transfer. We will discuss conduction in detail, and tomorrow we will be on YouTube for the complete mock test for BARC 2024. If you are not part of my Telegram channel yet, please do join me on the Telegram. The link is already there. So that is all from my side. Let me take your leave. See you tomorrow and today evening on the app. Till then, enjoy, take care, have a good day and a great career ahead. Thank you and Jai Hind.